Hi, I'm Helen. I run Osmond Education, which provides GCSE and A-level maths tuition to students around the UK and internationally. I am an award-winning tutor. I won Secondary Tutor of the Year at the National Tutoring Awards in 2024, and I'm shortlisted this year for Professional Tutor of the Year 2025. I also run a maths hub for tutors so that tutors can learn to develop their skills and do what they do more efficiently for their students. So I would say there's actually no typical way to teach. My style of teaching is very responsive and reactive to what the student needs. But you can see Michael, who has joined me as my guinea pig student today. So Michael is going to learn some maths with me today, and we will look at several options. Okay, so we're going to do a bit of geometry, or as we would call it sometimes here, over shape and space. So if I was working with Michael and I wanted to talk about different shapes, then one of the things that I can do here is I can go into various apps and then the resource library, and under mathematics, I've got the geometry section here. And for example, I've got 2D shapes, so I can drop in the image of a slightly rounded square. I've got a circle. They've all gone really big, so I'm just going to resize those really small. So this is one thing that you could prepare earlier, is have these all ready. Let's just make them all a bit smaller. So I've got some shapes here. As you can see with this one, I can flip it around the other way. I can make all my shapes bigger and smaller. Let's zoom back in. So what I could suggest to do for Michael is that to check his understanding, what I would like you to do is to sort these shapes into shapes with 4 sides and shapes without 4 sides. So let's say, for example, 4 sides. 4 sides goes over here, and I can even put a little line on it, and I can say not 4 sides over here. So Michael has quite quickly correctly identified here that a circle does not have 4 sides, a right angled triangle doesn't have 4 sides, but a square, a parallelogram, and a rhombus. So we've got our 4-sided shapes here. We could also do the same with, for example, 3D shapes. So one of the key terminologies here is a prism. So we've got a 3D shape. We're absolutely right with a 3D shape. It's a specific type of 3D shape, and the key thing is it has a constant cross-section. So the same shape all the way through. So again, if I wanted to sort these into prisms and not prisms, then I can go into my 3D shape and I can bring in an image of a sphere. Again, you could prepare this earlier, but if you do have a student that turns around to you and says, I need to do a little bit of work on 3D shapes because I'm not sure, then you can just come in and grab some 3D shapes. I'm just reducing the size a bit of these. Okay, so we've got a whole bunch of 3D shapes up here. So again, Michael, could you sort them then into the ones that you recognise have got a constant cross-section, so our prisms, and the ones that don't? Fantastic. Okay, could you then name any of these?
This is a cone.
That one's a cone, yep. And of course, I could ask Michael to either write or to type. There's a text box down here, so Michael could type his answers in. I'm using a Wacom writing pen. I encourage my students to have them because maths is not the easiest one to type, but certainly for something like this with labelling, you could do this. You could even prepare it earlier, and I could prepare some terminology. So pyramid, square-based, for example. I could write some out. So either handwritten or typed. We could make this a matching thing. So I could say, Michael, which one is the pyramid, the square-based pyramid? And he could then pick up the text and drag it into place for the right one. Fantastic. So any ideas on the orange one here?
This is just a tissue box.
It's just a tissue. Well, brilliant. Well done for identifying that, Michael. It's a tissue box. Yeah, that's an actual real life example of where we would see one of these. Obviously, you don't have the tissues coming out the top, but it's a tissue box. We don't call it a tissue box in maths. It does have a mathematical name. We would call this a cuboid, is the mathematical name.
And this is a sphere.
This is a sphere. Yeah, well done. So these are slightly...
Pentagon.
So yeah, so this one here would be a pentagonal prism because it's got a pentagon, quite correctly, so 5 sides on the top and it going all the way through. This one here has got 1, 2, 3, 4, 5, 6, 7. So it would be a heptagonal prism. Now again, it's a mouthful, that one. Heptagons seem to be one that students struggle with. They can do hexagons and octagons, but we don't always use hept for 7 in other places. We often use sept, like at September. But heptagon is like a heptathlon. It's 7 sports, it's 7 sides. We've got some real life situations here. If you want to make this real life, then you could import some images. You could have some in early. I could just grab a web browser here and go and grab, I'm going to stay signed out of Google. But if I picked up a Toblerone bar and I grabbed an image, okay, that's taken me to an American site, but I could see, give an example here, that this is a triangular prism because it's got the triangle on one side, the triangle all the way through. I always like that one because it gets me to buy a Toblerone. Cylinder then, a similar one would be a baked bean tin. Because we all know what a baked bean tin looks like. Most of us are used to what a tin is. We've got the circle and it goes all the way through. That one can also be really useful if to picture students doing it. If you do the label, you can see that you can, if you unwrap a baked bean tin, it makes a rectangle. So that can be really useful when we're starting to talk about surface area. Real life situations that students can actually picture what's going on. Especially online because we can't get them to manhandle things. So there's a little bit there on 2D and 3D shapes. I could ask Michael to easily pick them up and turn them round if I wanted the cone the other way up. Just click it and turn it. So then it looks more like the cone that you might see otherwise. I could get Michael to label these. So if I said, let's grab, I'm just going to grab a new one. Just so we've got it, let's grab a cylinder. Maybe I was doing some work on the volume and the surface area of a cylinder. If I said that this had a radius of 6 centimeters and a height of 12 centimeters, I could get Michael to draw those on there for me. Either just by writing, or we can use the shapes button here to give us straight lines or arrows. If it's not showing up well, I could get Michael to change the colour of pen. And there we go. Michael has correctly then identified the radius. He's put the radius on and not the diameter, which is always a nice relief, which is good. It's labelled on his diagram so that we can clearly see which parts that we need. We could then go and work out a calculation. Yeah, there we go. Quite clearly marked on all of the parts, all of the dimensions that we need on our shape. So that's one of the really useful things in here about doing the 3D shapes and 2D shapes that are in here. We also have, if I wanted to go into things up here, I have a quick little diagram here all ready to go that explains about circles and labeling the circumference, the radius and the diameter for a student on there. And I could quite easily get them to drop in. Here we go. Here is the formula already for working out the area of a circle in 2 different formats, either with the radius or with the diameter, and just remembering to change to halve the diameter. But if we're squaring it, obviously we're going to have the diameter over 4. You'll probably, if you're in the UK, use this one, is the one that we generally teach our students. But this is another format that would work equally well. So there are some areas and perimeters in here that can be really useful for labeling, getting students to see exactly what's going on, rather than relying on drawing them. All the way up to things like areas of ellipses. I could, if you're teaching A-level, I could drop in a triangle like this one, which is already labelled up. So we're talking higher T GCSE. Michael, I might just blow your brain now here, but if I said, okay, that when we're labelling our non-right angle triangles, can we see that this has not got a right angle in it?
Yeah.
Yep, no right angle. So this is a non-right angle triangle, which means we have to use slightly different labeling when it comes to our trigonometry. So when we label our triangles for non-right angle trigonometry, so we're talking cosine and sine rule and area of a triangle, our angles are the capital letters opposite the side. So the angles, we use the capital version, the capital letter, and it's opposite the side. So could you label angle A for me? So it's the opposite side to the lowercase. Okay. Absolutely correct. And we would then use capital A. Okay. So then which is going to be angle B? Fantastic. Last one left then is angle C. And it's really important then to identify those sides. So the triangle is there ready for me. I just need to use it to make sure my student is able to identify the sides correctly. We've got things like area of a square, area of a rhombus all written in for us. We've got some volumes, all of these prepared and pre-labeled. We've even got volume of a pyramid cone, so if it's a pyramid on the base, or volume of a frustrum if we're going all the way up into our higher tier GCSE. So there's a lot of different formulae and things in there all ready to go so that I don't need to worry about them.